everyone, in this video we are going to integrate or use this Chroma DB inside the LangChain library. So we know that LangChain is one of the popular library nowadays that we use to develop LLM or large language model applications. The purpose of this video, I will be explaining tools, whatever the terms we are going to came across. So what we are going to do in this particular video, first of all we are going to index documents using LangChain utilities inside the Chroma DB. Then we will retrieve those semantically similar documents for a specific query. Then we will see how do we store or let's say persist our Chroma DB so that you can load it and use it again somewhere else. And then we will see how do we integrate Chroma DB with the LLM. So we will see example of OpenAI chart models like GPT 3.5 or GPT-4. And then eventually the LangChain has the concept of chain where you're going to combine different things. So you can combine your Chroma DB prompt LLM together and perform some action. So we are going to see the question answering chain which can answer from the list of documents as a context, and then we will see there is another chain called retriever QA. So first let's start with installation of some libraries. Let's install first of all we need OpenAI because we are going to use LLM. From it we require LangChain because that's what we are going to use. We require sentence transformers. So the embedding that we are going to use for Chroma DB, we are going to use the sentence transformer which is open source embedding, and I will also show you the syntax to use OpenAI embedding. And then ultimately we want to install it, say the Chroma DB. So let's execute this thing. We require one more thing called unstructured. So the unstructured is actually a library used by the LangChain, and that library used when you want to read files from directory and process them. That's where we require activities unstructured. So let's install this one. Also we have setup documents that we are going to use as a part of this example. Those are the same documents here you could see where we are going to focus on whatever LangChain or Chroma DB aspect of tutorial. So in the LangChain you could use, so what we want to do, we have a document or let's say list of document inside a particular directory. So from the LangChain utility we can use something like document loaders and we can use the directory loader. This directory loader takes the directory path, and then using that directory loader we can load the documents and you will simply get the list of documents, right? So the document is some kind of a representation, the language you will, and we will see how does one document look like. So let's first up load those documents, and we are printing actually the length of documents, like how many documents we got. You see it is even using internally some analytic data. So we got the 5 documents because we actually have the 5 documents. Another thing is that so we want to store these documents into the vector database. So most of the time we will be chunking because those documents will be bigger, and we want to chunk them in a small chunks so that we can store them in vector database, and then we can retrieve those symmetrically similar chunks and then pass to LLM. So we can use LangChain has again utility for it. So the one of the popular recommended utility for text splitter is called recursively split by characters. So this is actually recursive text splitter. What it does here is the interesting thing. So it takes the list of separators that you can pass using which it can actually split your text, and this is what it does actually. First it try to make sure it gives all the paragraphs intact, like so first it will split at a paragraph level. Then if let's say adding paragraph is actually exceeding your character limit, then it will try to split based on the sentences, and eventually it will try to split on the page upwards. right? So it will try to keep those chunks, let's your text chunk as semantically together as possible. That's what it is actually going to do here. So that's where what we have used. So we are going to use recursive text characters text splitter. It takes what is the chunk size that you want to do. Let's say we have created one function here, right, which takes some chunk size as a parameter. Chunk overlap, since we know that it might split based on the particular words. Also, what if something like this happen, few words from the sentences go into the one chunk, the other words going to the other chunk, right? So to make sure we have our text at least properly presented, as at least one place we can add some kind of a chunk overlap. So if it is split, so what will happen? The two chunks will have, so we split chunks somewhere here, then what will happen? This part will go to the one chunk, and again some part of the actually go to the next chance. We can index now into the Chroma DB. So do that thing, we require some embedding. So what we will do from the LangChain embedding, we are going to use load sentence transformer embedding. Okay, and then we can use a particular model called this model all mini LM. This model we will be using, you can specify any other model whatever you want. Chroma DB uses some default model, right? So we have, let's say, let's load this embedding because we need to know, we need to download those embeddings. Another thing is that just like we imported embedding, so LangChain has a vector stores. It supports many vector stores, like Chroma is one of them. Okay, so other vector store also we are going to import Chroma from the vector stores of the LangChain, and then we can create Chroma vector database from the document. So it has a method that Chroma from the documents, and the list of chunks are tasks what we created. We can pass them, and we can also give the embedding that it should use this particular embedding to actually convert these chunks into vector, and it will get stored inside this particular vector DB so that we can retrieve relevant documents, right? We said, what are the different kinds of pairs people commonly on, because we know we do have one of the document which actually talks about. We specify our query, we take DB, and it has a method called similarity search. So the vector DB dot similarity search, we pass our query and we should get the matching documents, and you can see how does each document look like, and you could see this is the document object. That's what I was talking about, that it creates this representation the document when you create the chunks. So this document object, as you could see, it has a page content which is nothing but the text of that chunk, but it also has some metadata which mentions from which file this particular chunk belongs, because this is really important if you want to go and verify right answer. This is how you get the matching docs, and you could print it's a page content. That's we did right, we read the page content. Now with this chunk we can also pass some other parameter. Let's say there is a other function which also return the score matching score for this particular document, and then we can also specify how many such a chunk are docs. Each of them has a page content metadata, but then we will also have some extra thing which is called score. So this actually represents the matching score between this thing, right? Now this is how you can search symmetrically similar document, and that's what we have seen. As without actually using LangChain in the previous thing, this what we saw, the LangChain. Now how do we store this Chroma DB? So what we can do actually, so when we create Chroma DB or Chroma DB from the documents, we can also specify one more parameter called the persist directory. We can specify, let's say we want to store it here called Chroma DB, and then we can create vector db. Now if you call persist method, it will actually see we got this chroma db. Here we got this index and there are some other files what we got. So this is how you can save and can load it. So have saved it somewhere, then you can use it again. This chroma is coming from the vector store that we imported, okay, here. So we can take this chroma and if you give the directory path here, it will load your existing database from the directory. So let's call it as a new database and you can load that new database. Now let's go and see what is the retrieval QA. Again here, if you could see, chain requires matching documents and then query. Then retriever QA is another chain. What it does, it actually does this, finding the matching documents as a part of chain itself. So let's see what we need to create a retrieval QA. We again from LangChain, we retrieve retrieval QA. So we create object of retrieval QA. There's a function called chain. Again we pass the LLM. You can pass whatever stuff you want. But here we have one more argument called retriever and we want to pass a retriever. Retriever is nothing but component are the object which will go or which will retrieve that you know semantically similar documents from your vector database. So we going to pass retriever and then we can actually create retriever out of our vector database. So you can take your vector db as a retriever and we will get the retriever object that can be used. Then you can directly ask query every time. Actually there are lot of different chain. There is a lot of different syntax that how to load documents, how to create chunk. Make sure you explore the different text splitter. But since we are dealing with, let's say, vector database, open source vector database, I thought of using the open source embedding, right? And personally, I didn't find any much difference in using OpenAI embedding and vector. I always use, let's say, sentence transformer embedding, and then we saw how to create the chroma db from the documents, which is nothing but the chunk. We saw how to get those similar documents, even the documents with the score, how do we persist it, then how do we initiate question answering chain and eventually use the retrieval QA. So let me know if you have any doubts inside comment section. Maybe I'm thinking to create a dedicated tutorial on this stuff refine. There are different types. You can pass those documents to the LLM. I hope you found this video useful. Thank you.